Hey there! So in today's lesson, we're going to be going over adding and subtracting polynomials by collecting or combining like terms like we've been doing before. But I think that this might be a more organized way of kind of working through those types of problems because I noticed that we keep making very similar mistakes. So before we even get started, our method for adding and subtracting polynomials is through combination of like terms, right? Combining like terms or collecting like terms. So we should probably define what that means. And collecting like terms is when you're adding or subtracting terms with the same variable raised to the same exponent. Another way we can combine or collect like terms is adding or subtracting constants, so regular numbers. I'm going to write an example right under here just so that when I'm moving forward, I know exactly what I mean by collecting like terms. So an example of this would be, I'm going to insert equation. An example of this would be like 3x to the fourth plus 4x to the fourth. Because these both have an x to the fourth, what I can do is I can just add those coefficients together. So I can add the 3 and 4 together to get 7. And I'm going to keep my like term x to the fourth. Whenever I'm combining like terms, I should never change my exponent, right? My exponent always stays the same because I'm combining that like term. I want to keep that like term. So let's go into some examples of how we can use combining like terms in order to find sums or add polynomials. So let's look at this first example, right? So it tells us that our first step when we're combining like terms, when we're adding polynomials together, is to remove the parentheses. So I'm going to get rid of these parentheses here. So I'm going to click to edit. I'm going to delete that so that I can just start fresh. So I'm going to get rid of the parentheses. So it's just going to be 2x squared plus x plus 3 plus 3x squared. And in order to get that squared, I'm just pressing shift and 6 at the same time. And then I'm pressing the right arrow after I write my exponent to get out of the exponent writing. And then plus 2x plus 1. All right, so I'm done with my first step. Now I'm just going to collect my like terms. So when I look over here, right, I see that 2x squared is a like term with 3x squared, right? Because they both have an x squared. So I'm going to add 2x squared and 3x squared together. So let me just erase that. So 2x squared plus 3x squared, that gives me 5x squared, right? So 2x squared plus 3x squared, right? Those are my like terms. And then when I have an x, I have x and 2x. So those are my like terms. Now before I go forward, I just want to remind myself that whenever I have an x, my coefficient is actually 1. So I'm just going to put a 1 in front of there just to remind myself. And then my final like terms are my my constants, which are just like my regular numbers. And I see that I have a 3 and a 1 here, so those are going to be my like terms I collect. Now I'm just going to combine them. So just like I said before, 2x squared plus 3x squared, that gives us 5x squared. Notice how I'm not changing the exponent. Then I have 1x plus 2x, and that's going to give me 3x. And I have 3 plus 1, which is going to give me 4. So that's going to be my final simplified expression. Let's move on to the second example. So same kind of thing, I'm going to remove the parentheses, so I end up getting x squared minus 2x plus 7, and then plus negative 2x squared plus 5x minus 1. Okay? Now I'm just going to collect my like terms, so I'm going to group all my like terms together. So I have an x squared here. And remember, because I don't see a number in front of it, I'm just going to put a 1, just so I can remind myself when I'm combining my like terms. And when I scan my original expression, I see that I have minus 2x squared as a common like term. So I'm going to just write that right next to it. My next term in my expression is minus 2x, right? And then when I scan my expression, I see that I have a like term plus 5x right next to it. So I'm going to write it right there. And then I have plus 7. And then I scan my expression to see if I have another constant, and I have minus 1. So notice how I'm also bringing down the sign of the term, because that's going to be really important when we're simplifying. So let's work on actually combining those like terms. So I have 1x squared minus 2x squared, and that's going to give me minus 1x squared. And I have minus 2x plus 5x, so that's going to give me plus 3x. And I have positive 7 minus 1, which is going to give me positive 6. So that's going to be my final expression. So whenever we're working on adding polynomials together, we want to think about the steps that we want to take. So the first thing that we want to do when we're working through adding polynomials vertically, so we just did an example where we were adding them horizontally, is that we want to arrange the problem vertically. So that's when we're adding, let me actually note this. So when we're adding polynomials vertically. All right, so we just saw an example where we're adding it side by side, but now we're going to try adding them vertically. So we first want to arrange the problem vertically, meaning we take the first expression and then we stack it on top of the second expression. We're going to fill in any missing terms with 0 coefficients. And I'm going to show you what that means in just a sec. And then I'm going to add the problems. So that's going to be my step 3. And then step 4, I'm just going to simplify my sum by combining like terms. So let's look at an example. So notice how I have these two expressions that I'm adding together and they're stacked right on top of each other. Now when I go down each column, I want to make sure that I am lining up like terms. So when I look over here, I have 3x squared plus negative 2x squared. Those are like terms that are stacked right on top of each other, so I'm going to go ahead and just add them. So I have 3x squared plus negative 2x squared, that's going to be 1x squared. Okay. Now when I look at my next term, I see that they're stacked right on top of each other, so I have x plus negative 2x, which is going to be negative 1x. And I have 1 plus positive 2, so that's going to be positive 3. So luckily, all these terms were stacked on top of each other, so that made it really, really easy to do. However, let's look at this example over here. We see that when we look up and down these columns, these like terms are not aligned to each other, right? So we have negative 5x squared and negative x squared. That seems to be okay. However, when I look at this example, 17x plus 17, these are not like terms, right? Even though they have the same number value, 17, this first term has an x next to it. So this is not a like term to this constant 17. So I'm going to switch over to my tablet view so I can show you exactly what to do by replacing any missing terms with 0 coefficient. So the last time when we were on computer view, we saw that when we were trying to line up our like terms, right, vertically, we saw that although these were matched up, where when you look down the column, you have these like terms here, when we look down the next column, these are not like terms, so we can't put them right on top of each other. So I'm going to write my first expression, negative 5x squared plus 17x, right over here, right? And then I'm going to write my second expression underneath it. So I have negative x squared, so I'm going to put that right underneath my negative 5x squared because these are like terms, right? Now I need to figure out a place to put my plus 17. Now, my next expression should be a term with an x, right? Because that's what it looks like on my top expression. But I don't have a term with an x. So I'm going to replace that with a 0x, right? Just as a placeholder. And then I'm going to move on to my plus 17 right after that. Now, when I look at my top expression, I see that I don't have a constant term like how my bottom expression does. So just like I always did with this plus 0x, I'm going to put this right on top as a placeholder. So plus 0. So whenever I don't have that term that I need in order to make sure everything lines up really nicely, I'm just going to put in a 0 there just so that I know exactly what that means when I'm skipping that term. So I'm going to add going down. So I have 0 plus 17. That's going to give me 17. I have 17x plus 0x. This is really the same as 0. So this is going to be plus 17x. And this was a plus 17 over here as well, so I'm going to put that plus sign there. And I have negative 5x squared plus negative 1x squared. And so that's going to give me negative 6x squared. So this is going to be my final expression. So just like how we saw in tablet view, we saw that when we added by stacking or added polynomials vertically, it was really easy to kind of keep track of what my like terms were, just because I had to organize them so neatly before I even started adding. So for me, I think that adding polynomials vertically is easier, but it's a personal preference. You don't have to add it this way. You can add it using the horizontal method like we covered last time. But just like how we can add polynomials vertically or horizontally, we can do the same thing with subtracting polynomials too. However, whenever we subtract polynomials, we require one additional step. So whenever we're subtracting polynomials, we want to imagine that there's a -1 right in front of our subtracted polynomial, like right over there. Right? So actually, let me write this out over here. So I have 5x squared minus 3x plus 4 minus 1 times 2x squared plus 6x minus 1. Okay. So once I imagine this -1 in front of my subtracted polynomial, which is this polynomial right here, I'm going to distribute this -1 to every single term inside my parentheses. Right? So that means I'm going to multiply -1 to every single term in this second group. So let's try that. I'm going to keep this first group the same, and I'm going to actually get rid of my parentheses because I don't need them anymore. So 5x squared minus 3x plus 4. I'm going to start multiplying -1 with my first term in the second group. So -1 times 2x squared is going to give me -2x squared. Then I'm going to multiply -1 times 6x in my second group. So I have -1 times 6x equals minus 6x. And then finally, I'm going to multiply -1 with my last term, -1 over here. So -1 times -1 is going to give me +1. And so now I can actually treat this like a regular addition problem. So I'm going to move on to step 2 with that expression. So let me just copy this. Okay, so that's the expression that I'm starting with now in step 2. And I'm going to combine my like terms. So I'm going to put them right next to each other. So I have 5x squared, and I'm looking for a like term in this original expression. And I see that I have this minus 2x squared, so I'm going to put that right next to my 5x squared. I'm going to look at my next term in my expression, which is minus 3x. So I'm going to put that right next to my minus 2x squared. And I'm going to scan my expression for another like term to minus 3x, and I see that I have this minus 6x over here. So I'm just going to put that right next to my minus 3x. Now I'm going to move on to my next term, plus 4. Okay. And when I scan my expression looking for my next term that's like to to plus 4, I see that I have a +1, which is another constant. So I'm just going to write that right over here. So now that I've grouped my like terms together, I just need to combine them or add them. So I'm going to do new equation again. 5x squared minus 2x squared is 3x squared. -3x minus 6x is minus 9x. And then +4 plus 1 is going to be +5. And so that's going to be my fully subtracted expression. Now, whenever we are subtracting polynomials vertically, we want to make sure that we're doing something similar to what we did with adding polynomials vertically. Just like before, there's one additional step compared to adding polynomials vertically, and it's just to make sure that the polynomials are in descending order. So that just means that your exponents are going from highest to lowest. So over here, they're going from highest to lowest because this doesn't have an exponent. And over here, they're going from highest to lowest. So we start with the exponent of 2, then an exponent of 1, and then an exponent of 0. So both our polynomials are in descending order, so we don't actually have to do anything for our first step. Now, I'm going to switch over to tablet view, where you can see how I can kind of just line these up vertically, and you can see how I can subtract polynomials vertically. So I suggest that you take out a piece of scrap paper, and I'm going to switch over to tablet view. Okay, so we're going to start off with step 2 because we already made sure that all of our polynomials are in descending order. And I'm going to write the polynomials vertically with the like terms aligned, just like how I did for my addition problem. So I'm going to write -3x plus 4 first, and then in my second expression that I write underneath, I have 2x squared, right? But I don't have a like term to 2x squared in this first expression, so I'm just going to write it out here. I have 2x squared and plus 6x, so I can line it up with this minus 3x, right? Because those are like terms. And I have minus 1, which is a constant, and I can line that up right with this constant over here. So that's my subtraction problem aligned up. Now I want to replace any missing terms I have with terms that have a 0 coefficient. So like I said before, this first expression is missing this x squared term. There's nothing lined up with this x squared term. So I need to replace a 0x squared term right over here just as a placeholder. So I'm going to write 0x squared minus 3x plus 4 minus 2x squared plus 6x minus 1. Oops. There we go. Now that's really nicely and neatly aligned. Now I'm going to multiply the bottom polynomials by -1. So this is just like how we did before when we were distributing that -1 to that second polynomial. In this case, our second polynomial is in the bottom. So when I do that, I'm going to keep my first expression the same. So 0x squared minus 3x plus 4. And now I have -1 times 2x squared, so that's going to give me negative 2x squared. I have -1 times 6x, that's going to give me minus 6x. And I have -1 times -1, which is going to give me positive 1. And so now I can move on to step 5, where I'm just going to add these polynomials now. So I have 0x squared minus 3x plus 4, and then minus 2x squared minus 6x plus 1. I'm going to add these. So I have 0x squared plus negative 2x squared, so that's going to give me negative 2x squared. I have negative 3x plus negative 6x, that's going to give me negative 9x, so minus 9x. And I have positive 4 plus positive 1, that's going to give me positive 5. And we end up getting the same answer as before. We were just approaching the same problem using a different method. So now that we've learned how to subtract polynomials both side by side and also by stacking them vertically, we have 2 practice problems that we want to try out. So try this out on your own first, and then you can come back to this video to kind of just see if you got the answer correct. And I'm going to be using both methods to do this. Alright, you ready to check your work? Let's check our first difference. So let me just zoom in a little bit here just so we can see it a little clearer. So just based on how this problem's written, it's written horizontally. So this is telling me that I want to solve this problem horizontally. So the first thing that I want to do is I'm just going to write it over here just so I can understand it a little bit better. And then instead of writing this minus sign by itself, I'm going to write -1, so I know to multiply this second polynomial group by -1. Okay. So now that I've done that, I want to do the distributive property for this -1 over here to every single term in my second group. So I'm going to take this -1, I'm going to multiply it by x squared. So I'm going to get -1x squared. I'm going to multiply -1 with 2x to get -2x. I'm going to multiply -1 times +1, which is going to give me -1. Now I didn't do anything to this first expression here, so I'm going to bring it down right over here. So I end up getting 2x squared plus 2x plus 3. Now I'm going to group my like terms together. So I first see that I have 2x squared here and -1x squared here. Those are like terms, so I'm going to put them right next to each other. 2x squared minus 1x squared. And then I have 2x and minus 2x, so plus 2x minus 2x. And then my last term is going to be plus 3 and minus 1 right over here. So plus 3 and minus 1. So now that I've grouped them together, I can start combining my like terms. So I have 2x squared minus 1x squared, that gives me 1x squared. I have 2x minus 2x, that actually cancels out to 0, so I'm not going to write a term there. So I'm not going to write a term there. I have plus 3 minus 1, so that's going to give me plus 2. So I have 1x squared plus 2. Let's try out the second one. So when I look up and down these columns, I notice that these terms are not like terms. So my like terms are not aligned, so I'm probably going to have to put a 0 coefficient somewhere as a placeholder. So I'm just going to write this top expression one more time. So I have negative 3x squared plus 4x minus 1, right? I notice that my polynomial is going in descending order because I have the highest exponent here, and then it just gets smaller and smaller. And same thing for my bottom expression too, right? I have my top exponent, and then I keep going smaller and smaller. Now for my bottom expression, my first term is negative x squared. So I know that should go under this negative 3x squared. So I'm going to write that, negative x squared. And then my next like term is this minus 4x. So that should go under this positive 4x right over here. And then I'm missing a term to go under this minus 1. So I'm just going to fill it with a 0 coefficient. So I'm just going to put a plus 0 right over here just as a placeholder. So now when I look up and down each column, I see that all my like terms are very nicely aligned to each other. Now all I need to do is multiply by negative 1 to this bottom polynomial. So I have negative 1 times negative x squared, and that's going to give me x squared. I have negative 1 times negative 4x, so that's going to give me positive 4x. I have negative 1 times 0, so that's going to give me just 0, right? I'm going to write this top expression right on top because I didn't do anything to it. And now, because I just multiplied by negative 1, I can just add my two polynomials together. And I can go down each column. So I have negative 3x squared plus 1x squared, right? That's what that means. And that's going to give me negative 2x squared. I have 4x plus 4x, right? So I'm reading down this column. So that's going to give me 8x. I have negative 1 plus positive 0, which is going to give me negative 1. And that's going to be my final answer. So hopefully this was helpful to you. Make sure that you are writing this in your notes, and then you can resubmit any practice problems that you were struggling with before. And if you have any questions, just make sure to email me. Good luck.